Hey guys, Mr. Middleton here. Today we're going to look at vectors notes. At the end of this video, you should be able to find the magnitude and direction of a vector. You should be able to write a vector in component form, and you should be able to take a vector in component form and find its magnitude and direction. Okay, a vector is a quantity that has magnitude and direction. That means it has an initial point, starting point, and a terminal point or ending point. The distance from the starting point to the end point is called the magnitude. The direction corresponds to the direction the arrow is pointing. Okay, it can be represented by a coordinate pair in the coordinate plane. It's called component form. Okay, so just setting some of the terms that we're going to be using and getting used to as we go. So here's an example. We have a vector here. You'll notice that it gives us the length of OL as 65. That length, that is our magnitude. Okay. We use our direction. For the direction, we actually use the compass rose, like this: north, east, south. And the direction of this value, when you say our direction, we'll use the angle measure. In this case, it's 50 degrees. Okay, and then what we do is we look at the direction it's going from the direction it started. Okay, so it's going south from the west. So we call it 50 degrees south of west. Sorry, I said south of west. South of east. It's going south starting at the east. So 50 degrees south of east. Our initial point was O. Our terminal point is L, right? Because it's starting from here to there. And then in component form, what we're looking for is we're looking for our X and our Y values. Okay, and so later on, we'll look at how our trig ratios play into finding what X and Y are in this case, rather than just saying X and Y. Okay, so that's all the terms we just kind of talked about there, laid out in front of you. All right, so let's talk. Let's get to this a piece at a time. Let's start with using the direction. So here, we are given a vector, and it's asked us to give the direction of each vector. And so we have 35 degrees, the angles here. Okay, remember that as we name this, we start with the angle measure, which is 35. And then we go to the direction it's opening toward, so it's going east. And then from the direction, or of the direction it's coming from, of north. So you notice in this problem, it's 35 degrees heading towards the east from the north. 35 degrees east of north. Okay. There's actually two ways to name these vectors. Okay, so you'll notice that I did 35 degrees east of north. But in each quadrant, there's 90 degrees. So this is 35 degrees. This will be 55 degrees. We could also name this, if we wanted to, not that we necessarily want to, 55 degrees if we're going. So a couple things you'll notice about these complementary names is that they are complementary. They add up to 90 degrees. Okay. And then you see that we would change or flip the order of the compass rose directions. Okay, so typically though, we focus on just naming it the way that they've given us the information. So our second example, you can try that out. Asks us to find the direction of this vector. And so we would call this one 25 degrees south. And the last one, we'd call this 20 degrees west of south. Okay, so like I said, we're going to kind of investigate how to get everything that we talked about in this first section, started with the direction. Let's go to component form. It says describe OL notice the symbol that our OL, it's like this is vector. Okay. Describe vector OL in component form. Give the components to the nearest 10th. So they're asking us to find X and Y. Okay. So we have this triangle. We're asked to find X and Y. You'll notice that this is a 90-degree angle, right, on the coordinate plane, horizontal, vertical, makes 90-degree angles. Okay, and so we need to find X and Y. We use our trig functions. Remember that our process for that, identify the sides. This is our opposite. This is our hypotenuse. This is our adjacent. And this is our hypotenuse, 65. Okay, so I'm trying to find the adjacent side. I know the hypotenuse from the 50-degree angle. So adjacent hypotenuse tells me to use cosine. So I'll use cosine 50 equals our X adjacent over our hypotenuse, 65. Okay, and now I just solve for that. 65 times cosine 50 should give me X. And what will that be? 50 cosine times 65. And that's 41.78 or 41.8. Okay. Now, because we're on the coordinate plane, it is very important for us to make sure that we pay attention to positive and negatives, right? On a coordinate plane, going to the right is positive, going to the left is negative. Going up is positive, going down is negative, okay? Our calculator will always give us a positive answer. Okay, but it'll be up to us to make sure that that's the correct answer. Okay, so as we look for Y, it's the opposite side, hypotenuse. Opposite hypotenuse tells us we're using sine. Okay, so for Y, we'll say sine 50 equals the opposite Y over the hypotenuse, 65, and we'll do 65 times sine 50. Okay, so now back to our calculator. Sine of 50 times 65, and that gives us 49.79, so it's 49.8. Okay, again, it gave us a positive answer or a positive number, but looking at our coordinate plane, we'll notice that it's going down. So it's up to us to say, hey, this is negative 49.8. Okay, so in component form, we're finding our X and our Y value for this triangle, basically for this triangle using the magnitude of the vector as a hypotenuse. So here's an example. You can look at that, try this out really quickly. Go through it. All right, so it's asking us here to describe this vector using component form. Give each component to the nearest 10th. So we have the hypotenuse of 371, and we're going to be trying to find the X and Y coordinates. Okay. Okay, so here, as I'm labeling my sides, I have the opposite here. This is the adjacent. And so I'm going to say, and I know the hypotenuse. Okay. So from this angle 21, to find X, I say sine 21 equals opposite X over hypotenuse 371. So 371 times sine 21. Okay, and that'll give me X. Define Y. It's adjacent hypotenuse cosine. So cosine 21 equals adjacent Y over hypotenuse 371. 371 times cosine 21. Okay, so I have those values. Now I'm going to plug them into my calculator. I wanted to get that all down so I didn't have to bring up and down the calculator multiple times. So my calculator so I can actually write on it. Sine 21 times 371. And that gives me 132.95. So I'll say 133. and then back to it. 21 cosine times 371 gives me 346.35 or 346.4. Okay, so here we find our x value, we find our y value, or at least our number for it. Remember, we have to check it goes to the left, so our x value should be negative 133.0. And our y value goes down, so it should be negative 346.4. Okay. Just another reminder that we need to make sure that we're checking where it's at on our coordinate plane and not just looking at our calculator. Okay. Here it says find the magnitude and direction, okay, given component form. So here they give us negative 8, 15, and how we can think about that is they've given us the coordinate for where our magnitude, our vector ends. So negative 8, 15 would be somewhere right here. That's what they've given us. Now, we know that this line's from here to here, but what we don't know is what the length of this line is, or the magnitude of this line is. We find that out first because it's a right triangle. This is 15. This is 8. We can use Pythagorean's theorem to find out what our magnitude is. Okay? So 15 squared plus 8 squared should give us x squared. It's 225 plus 64, 289. X squared, I believe that's 17. Square root, yep, 17. All right, so we find out that the magnitude is 17. All right, now we have to find the direction. The direction, we're looking for the value of this angle. Okay, we've done this before. All right, so we have the opposite and the adjacent side. That means we'll be using tangent. So tangent of y, because that's what I call that angle, equals opposite 15 over adjacent 8. Notice that we do not use negative numbers here. Okay, so we do not use negative numbers in our ratios, even though it's a negative component, or negative in our component form. Okay, so now to find y, it's going to be the inverse tangent of 15 over 8. So 15 over 8. All right, I'm going to go to my trig, go to the inverse tangent of that, and that gives me 61.92 or 61.93. The directions ask me to round to the nearest whole number. Okay, so 62 degrees. All right, so in here, 62 degrees. So, looking at how I made that angle, all that jazz, we can call this 62 degrees north of west. All right, because it's going from here to here. So, magnitude is going to be 17, and then the direction is going to be 62 degrees north of east. All right, try this next one out. Negative 12, negative 7, be here. So this will be 12 and 7. All right, so to find my magnitude, I do 7 squared plus 12 squared equals x squared. Just call it m squared. Okay, so 49 plus 144, and that's 193. Make sure I'm right about that. Yep. All right, and then we take the square root of that, and that gives us 13.89. Okay. So So it gives us 13.89, but our directions say give each number to the nearest whole number, so we'll say magnitude of 14. Okay, so we know our magnitude. To find the direction, we will use opposite, adjacent, so tangent. And tangent, I'll call this x, equals the opposite 7 over the adjacent 12. To find out what that is, we're going to have to do inverse tangent of 7 over 12. Back to my calculator. 7 over 12. Now we're using the inverse tangent. And that gives us 30.25. So we'll call it 30 degrees. Okay, and you'll notice it's going here. So south west. Okay, so magnitude of 14, direction 30 degrees south of west. All right, so here are 2 answers for those. Yo, that was a terrible line. All right, last problem here. Nope, last 2 problems here, looking at some word problems. It says Barcelona, Spain is 207 kilometers north and 428 kilometers east of Madrid, Spain. On a direct line, how far is Barcelona from Madrid to the nearest kilometer? Describe the direction from Madrid to Barcelona to the nearest degree. So here, look at our plane. We're going to make a coordinate plane of this. And we got Madrid here. Just label this point M. Okay, and it says Barcelona is 207 kilometers north and 428 kilometers east. So as I look here, this is 428. This is 207. All right. So on a straight line, they're asking us, hey, on a straight line, how far is this? They're asking us what this distance is. All right. So we can find that using Pythagorean theorem. 428 squared plus 207 squared should equal, I'll just call it distance squared. All right. So use my calculator, 428 squared plus 207 squared. Is that doing it right? Okay. Equals 226,033. All right, equals d squared, right? And so in order to find out what that distance actually is, we have to take the square root of that answer. And that gives us 475.4. Okay, directions tell us around to the nearest whole number. So 475 is what we'll say. Okay, then it asks us for the direction of it. So we'll call that x. And so we have opposite over adjacent. That means we're using tangent. Tangent x equals the opposite 207 over the adjacent 428. Find x by using inverse tangent of 207 over 428. So back to my calculator. 207 over 428. We're using the inverse tangent of that. So 25.8. And since it says to the nearest degree, we'll say 26 degrees. And then we'll say north of east. All right, so there's our direction. There's our distance. Probably say kilometers, 475 kilometers. Okay. Finally, a bird flies 73 degrees in a straight line to a point that's 41 degrees west of north from its original nesting site. Give the bird's final nesting site in component form. Round it to the nearest tenth. Okay, so here we go. 41 degrees west of north. So we got north here. We're heading towards the west. Where we're at, that's where our 41 is. and they told us that this is 73 feet. Okay, so we have this triangle. They're asking us to give component form, so basically that we need to find x and y here. Okay, so as I label my sides, this is the opposite, this is the adjacent, this is the hypotenuse. In order to find x, I'm using sine, so I'll use sine 41 equals the opposite x over the hypotenuse 73. 73 times sine 41 should give us x then. Okay, we'll do the same thing for y, except now I'm using adjacent to hypotenuse, so cosine 41 equals the adjacent y over the hypotenuse 73. 73 times cosine 41 equals y. All right, use my handy dandy calculator. Okay, so here we go. We have sine 41 times 73. And that gives us 47.89. So to the nearest tenth is 47.9. Okay, that's our x value. And then back to it, do the same thing for our y value. We use 41 cosine, so the cosine of 41 times 73. And that gives us 55.09 or 55.1. Okay, so these are our values. Remember that we always want to check to make sure that our positives and negatives are correct. So for my x, I go left, so it's negative 479 or 47.9. For my y's, I go up, so it's positive 55. Okay, and so here's my component form of the new nesting place for that bird. All right, that's that. See ya.